try to keep this very short. I'm Allison Gage. I'm the president of SOFIA. And we're here to welcome Bill Nye to Minneapolis. So we've got some demonstrations for you. You may have heard about something called the Flip Classroom for all of those who are prepared for this event. We're going to have the largest live Flip Classroom today with Bill leading it. And we also asked you to look at some videos before this, but don't worry if you didn't. We will show the video again before Bill Nye comes up. So here's how it's going to work today. I'm going to welcome Bill Nye here in just a minute. He's going to walk through one of the many lessons that we have that he has published on SOFIA. And then you'll review it as a group. We'll give you a very short quiz. And then we're going to, and for all of you teachers who are out here, remember that all of these tutorials that we're going to be showing you today are available to you for free on SOFIA.org. So feel free to use Bill Nye's lessons or any others to flip your classroom as well. So after Bill shares the Flip Classroom lesson, we're going to watch him compete some big-time science demonstrations. Are you guys excited for that? So he's also going to have help
This will drip a little bit, but it should hit you.
Donna Grace Moletta, a high school senior from New York, who won our back-to-school campaign with Bill Nye, our contest. She completed one of our SOFIA Pathways for college credit courses, which is eligible for college credit across all the colleges and universities in the United States. So she's here today to help Bill with some of the experiments as well. So without further ado, I'm going to be introducing Bill Nye. Bill Nye, come on up here.
Thank you, Allison. Thank you, Allison. Thank you. Greetings, greetings, greetings. Greetings, ladies and gentlemen, boys and girls, kids of all ages. How you guys doing? So, how many people love homework? What? Okay. No, so we have this program called SOFIA.org. How many people have not heard of it? Weird! Anyway, so here's the idea. Instead of going to class and listening to the teacher for the whole time, instead, the night before, you watch a little of the classroom, of the lecture, of the lesson at home, on your tablet, on your computer, on your phone. And then when you get to class, you have more time with the teacher. That is, as we say in comedy writing, the premise of the bit. So this is SOFIA.org, and here's a little something I did, I guess it was a couple years ago. Can we, as we say in the business, roll that video?
Hey, Bill Nye the Science Guy here with a classic demonstration involving fire and atmospheric pressure and some chemistry, some combustion chemistry. So here is a water balloon, a pretty small volume of water in a balloon on a glass classic milk bottle. The water balloon doesn't fit inside. But if one lights a fire in there with, say, this very small scrap of paper, some of the gas that's in the bottle right now will be driven out into the room. And the balloon will shake as the hot gases go by. But as soon as the fire goes out, atmospheric pressure pushes the balloon into the bottle as though driven by a giant's thumb. Well, anyway, the balloon is stuck, and I'll show you. If you grab the knot of this balloon, you can pick up the whole bottle. That's because air cannot get around the balloon back in the bottle. The balloon holds its shape in the bottle. But using an ordinary straw, this I guess is a coffee stirrer that's hollow, placing it next to the balloon, now air can go through the straw to the back of the balloon, and the balloon will distort and come right out, as if by magic. But it's not magic, my friends. It's science.
So let's say you did that at home over and over again. Then we were able to ask you a few questions. Let's try one. When the temperature of the air in the bottle goes up, the pressure in the bottle goes down. Is that true or false? The pressure goes up because the hot the fire is making the molecules move faster, they expand. So the pressure is slightly higher. That's why the balloon was shaking on top. Let's try the next question. The pressure is lower inside the bottle because the oxygen is gone. True or false? Right on. By the way, an interesting point of interest. My colleague on the board of the Planetary Society, a dear friend of mine, a guy who spent the night in my guest room many times, a guy who knows the password to my wireless router, Neil deGrasse Tyson. At first, got this one wrong because his science teacher many years ago sort of approximated it or did a hand-waving explanation about how the oxygen was gone. It's not that the oxygen's gone. It's that all the gas has been driven out by the expanding, the oxygen and carbon dioxide, everything's been driven out. All right, when the hot gases in the bottle escape, the pressure inside the bottle goes down. Let's say the fire's gone out. Does the pressure go up or down inside the bottle? How many people say up? How many people say down? Yes, yes. So that one's true. Click. Bing, bing, bing. Now, Jay, tell us what they've won. You've won a new car. No, wait. No, wait. A little bit of an exaggeration. No, so can you imagine that you're at home and you have a milk bottle or you acquire one or you met somebody who lend you one and you could do this over and over again until you figured out these subtle things. The reason this demonstration is so popular is because, first of all, it's just cool, right? The balloon's there and then it goes in. And how many people grew up with a hard-boiled egg? Same, so you can do the same demonstration. My friends, I am so old. How old are you? I am so old. I remember when the milkman, and it was always a man, came to the house with milk bottles. Oh, those were the days. And now milk bottles are making a comeback because everybody finds that glass is such a fantastic material to store liquids in. It's solid rock, yet you can see through it. Is it magic? No. It's, yes, yes. And so you can do that demonstration over and over to figure out the subtleties, because it is a little surprising. The hot gases go past the balloon. When the fire goes out, atmospheric pressure pushes the balloon in. It's cool. It is part of the flipped classroom at sophia.org. What is the name of it? It is, yes, I love you guys. Now, enough messing around. It's time to do some science. And for that, we're going to bring up my colleague and new best friend, Andy Runquist, Hamline University. Andy is fabulous with this. Why, what do you have there in your hand?
I have a candle.
That looks very dangerous, Andy.
It is very, very dangerous.
Andy, if I were to light this candle, you know that you could, oh geez. You could take that candle, Andy, walk up to this backdrop and set it on fire.
I know. Should I do that?
That would set the white thing on fire.
Yeah.
Who knows what would happen? The wire insulation would catch on fire. The carpeting would catch on fire. The Mall of America would catch on fire. Minneapolis St. Paul would be destroyed. Albert Lee would disappear. Or you could just be careful with it because it's a candle.
I'll try.
So you have a lot of experience with this.
Yeah.
Can we bring in somebody to help us?
Yeah. We have someone to bring in. Donna Grace, do you want to come on up?
Donna Grace.
Sorry. That's all right. You want it? There you go.
Won a contest. Are you wearing a microphone?
No.
Yeah, I will lean in. You won a contest, right?
That is correct.
And contest was sponsored by what unique organization?
Sophia.org.
Yes! And you wrote a tweet.
I wrote a tweet. Yeah, I wrote a tweet.
What was the crux, the high point of the tweet?
I heart Bill Nye with all of my hypothalamus.
Oh, yes! I love you. So, Andy, I'll watch while you deploy your trombone.
Well, before we do the trombone, we want to talk about how you blow out a candle.
Oh, good point.
So can you demonstrate, Bill? Do you think you could do it? Try. Do you need some fanning? All right, here we go. Yeah!
Now, Donna Grace, we've been down this road about setting the stage on fire, the thing, the Albert Lee joke and all that. Yeah. Okay.
Safety first. So what did you do, Bill? What was involved?
Well, based on that last demonstration you saw with the milk bottle, you might think that when I blew on it, the oxygen was used up, and that's what put out the candle. I submit to you that that is not the case. It is instead that when I blow on it, I cool the wick of the candle off so fast that it cannot sustain its combustion. The fire triangle, fuel, which in this case is...
Oxygen?
How about wax?
Wax.
Wax. Oxygen, which is...
A gas.
Oxygen. And then the third one, do you remember, of the fire triangle?
Nope. Heat.
Yes! Brilliant. And so you cool it off, and we will show you that it is not the carbon dioxide from my breath that extinguishes the candle. Now, Andy will use sound waves. Is that right?
Yeah, well, we're going to have them use their sound waves.
Oh, cool. Okay. Oh, cool.
So one of the things that's really interesting is we need the air molecules to move. We need them to move fast. And so we could all blow it out, but we don't know if you've brushed your teeth today. So instead, what we thought we would do is move the air molecules around here in a way that's pretty easy to do over long distances. And that's the sound that you hear right now. If you can hear me, I'm moving the air molecules in your ear right now, even the people way up there. So the question is, can we work together using sound to blow this candle out?
Well, I don't know, Andy. Can we?
Well, let's give it a shot. So on the count of 3, we're going to scream at the candle. Be prepared.
What are we going to yell?
How about science?
Science. Good.
So, Donna Grace, this is going to be loud. Are you going to be able to handle it? Okay. On the count of 3, we're going to yell science right at the candle. We're going to see if we can blow it out. 1, 2, 3. Science! Not much. Not much.
Andy, that's it?
I know. Sound is like nothing.
That's it?
I can be louder, though. You want me to be louder?
I'm not sure.
All right.
Oh, the head of the Hamlin University pep band happens to be on stage with us.
All right, so trombones can be really loud. I would not recommend putting your ear right next to this. But what's going to happen if I walk all the way up to it while playing a note relatively loudly? Question is, can I blow the candle out? Are you ready?
One test is worth 1,000 expert opinions. Andy, that was nothing, dude.
I know, it's like nothing.
Yeah.
We got anything better?
Yes.
What do we
rotate that to keep the wax going.
So sound, you guys. Sound can be loud and moves the molecules in your ears, but it's not enough. We've got something that can move more. You want to try this sucker? Oh, you're going to give her a stool. All right. Do you want to try it?
Oh, I'll try it, yes.
Go ahead.
This is the Mark I vortex ring generator. Yes. To the untrained eye, this might look like a trash can. But oh no, my friend. So, Donna Grace, if you would stand 90 degrees to what you are right now so people behind you can see the candle. Then, using the equipment we have here, can you hold the candle a little lower? So I submit to you that when I compress the volume inside the trash can of science, we will produce a pulse of air suitable to extinguishing the candle. 3, 2, 1. Oh! Yes! Bill Nye came to the Mall of America and blew out a candle. Yes! I've never seen anything like it. It was astonishing.
But Bill,
now,
they can't
Andy,
see what they're doing. You want me to make it so you can see?
well, so here's what I'd like you to do. Hey, girlfriend, excuse me, my esteemed colleague, we're not done.
Safety demonstration. Whoa.
There's quite a breeze in here. So now I'm going to block the air with this ordinary piece of paper, except it has my logo on it. This is a piece of paper of science.
Are you ready?
Yes.
One more?
Yes. And I'll show you one more. Oh, I got me a little more a little softer, yeah. No, you hit it harder, so that's not what I meant. I have to hold the paper with less. Yes. So it blocks the candle. Now, Donna Grace. Oh, hold it. Wait, nobody leave this room. Nobody leave this room. Do you recognize this?
Yes.
You blow words into it, so when they pop, they swear. All right. So do you recognize it now?
Yes.
What is it?
It's a balloon.
What'd you say?
It's a balloon.
No. I mean, sort of. Now what is, oh here, sorry. Now what?
I don't know, it's backwards.
It's a fish.
Obvious, obvious.
Oh, by the way, see this pen? You know who gave me that? I'm not joking you, just dropping some names. That's how cool I am.
Name dropper.
Neil gave me this. Neil Tyson gave me this.
Are you ready?
3, 2, 1.
You blew it out.
No. So what happens, the air pressure in the room constrains the pulse of air so that it is held on the surface of the balloon. It gets to the back and cools the candle wick out just like that. It's not magic, it's yes! Now, what do you think the shape of the pulse of air that comes out of the trash can? Oh, you all are so smart. You might think it's a sphere or a ball. You might think it's a bullet shape or a torpedo or something. But it's this right here. Take it. 3, 2, 1. Oh. So you'll notice right there the ring went right around the candle and did not extinguish it.
Again?
Yeah. Woo! And so when the ring hits the candle, it puts it out. It's not magic, it's... Well, keep blast it.
Blast
Party
it.
on, dude. Hey, that's really cool. Thank you. Stick around if you can. So here's a step in thought for those of you looking for steps in thought. When we're up here talking, when you're talking to each other and so on, the molecules of air are bumping into each other at the speed of sound, yes, not the speed of light, yes, speed of sound. And so they're not moving between me and you. They're just bumping into each other. But in this case, we have a ring of air passing through air. And this subtle and amazing thing, it turns out when you push it, when the equations are elegant and beautiful, everything cancels out and you get a ring with the air spinning in a ring. And so because the air is both spinning in the ring and moving, it has enough airspeed to put the candle out. So, Andy, if you would, push it pretty gently.
Okay.
But you'll notice there's quite an airflow up here. I have to block the lighter to energize things. Give it a slow push. Yeah, so now nose up ever so. Boom! Now, so even when it's not moving fast, it puts the candle out because it's both translating and spinning. It's not magic, it's science! Yes! Sophia.org, yes! Oh, My favorite. Let's say we were to throw a Frisbee like this.
Awesome. This looks like a fun game.
Brilliant. People call it pancake toss.
Yeah, yeah. Does anybody over here know how to throw this? You know how to throw this?
Okay.
Stand up. Can you throw it to me? Yeah, whatever.
Oh, that's not bad, the thumber. Yeah.
Ooh, nice.
Yes.
Thank you.
But she was going to do the...
I'm no good.
She was going to give us the top thumb like that.
Oh.
Yeah. So then, there's a remarkable thing about spinning things. They have momentum even when they're not moving like this, when they're just spinning. They have momentum, right? But when you exert a twist on them, everything works at a right angle. So this will be our first experiment on this short stage, but when things are spinning, they have a different stability.
Oh, bad. You can do it.
They could have played pro ball. And just let the record show it works this way too.
Oh.
So you want to hit the outer edge of the disc, and it doesn't turn. Here, may I have the disc? If I hit this edge of the disc, it doesn't turn this way, it turns this way.
Science.
And that's the nature of spinning things. Here's one.
Yeah, so, normally if you just let something sit here and try to balance it as best you can, make a prediction how long it's going to stay up before it flops over. If you think it's 1 second, clap once. If you think it's 2 seconds, pat your head and rub your belly. If you think it's 3 seconds, rub your head and pat your belly. If you think it's more than 3 seconds, pick the nose of your neighbor.
It's a little troubling, Andy.
All right. All right, let's see. Ready? I'm going to balance. 3, 2, 1. Not bad. But watch what happens if you spin it. It stays up forever. It just won't fall over because rotation is what provides the stability. It's not magic. Awesome. So, we've got something that spins around. Did you want me to go with this?
It looks like a bicycle wheel to me.
It's a bicycle wheel, but it's interesting because if you put a lot of weight outside when you spin, you have a lot more rotational inertia. You like to rotate for a long time. So instead of blowing this up with air, I cut a little hole in the tube and I filled it full of lead shot. So this thing's really heavy. But if I get it spinning, it just goes and goes and goes and goes. What's interesting is
you can't let go with that hand,
I'm going to let go of this hand.
My goodness.
Do you want to sit down below it and let it fall on you? All right, here we go. I can just go right, just like that. Are you ready? 3, 2, 1, science! So what's cool about this is that it works even if you tilt it up. It works if you tilt it down. Just keeps on going. Now gravity is making it do something weird. What's up with that?
What's down with that, I think. Yeah.
What's down with that?
So as you may know, ladies and gentlemen, what is a property of matter? Yes! Inertia is a property of matter, and this has both the inertia of its overall mass, but it has the inertia from its spin. It's not magic, it's science! Yes! Yes! And so it is perfectly analogous to the spinning disc, which gets, when you strike at one edge on the ground, it noses up. Oh yeah, really good, Bill. Yeah. But you can also make it nose up just with pressure, which is fun. Oh, nothing but fun. All right, so, Andy, this is a fabulous thing. So, where are all these twists being resolved? Where are they going? I mean, you're holding it by a single string and it's not falling over.
Yeah, and
there's something twisting to hold it up in inertial space.
Yeah, it's not falling down. One of the things I like to do when I do my show at elementary schools is I ask them, when it's spinning, it doesn't flop over. But what if you made it flop over? What if you could be strong enough?
What if I forced it to flop over?
Do you want to do it or you want to try it?
Well, I've happened to have taken a seat on this stool.
Excellent. So what kind of stool you got there?
I don't have an ordinary stool. I have a stool that lets us do this. By the way, in the beginning of the Science Guy show, I put on a green cape and spun around like this. That's how we did it. And then we erased the green. And yeah, after a half hour, I'd had enough. Yeah.
All right.
Woo.
So
But you can see, I'm fine now.
So here's the rope.
There's the rope. You want me to hold it with one hand?
Well, you should put the other hand on the other
I
side.
was going to say.
Can you reach it?
Yep. And now I'm going to
flip it
twist
over.
it. Let's do it this way. Wait, I'm twisting the wheel and the bench is turning. This is crazy. What if I went the other way? Oh my goodness, this is proof of the paranormal. And you'll notice, ladies and gentlemen, that when you wear a bow tie, it doesn't get caught in the spinning wheel. And you know what we say right there, Andy? Safety first.
Safety first.
Safety first.
All right.
Or pretty, you know, early. If not first, early.
So, sound.
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 Oh.
So, we want to talk a little bit about sound. This is a tube with air in it. Can you verify this is a tube with air in it?
Yes, it's
Verified. But it's got little kinks in it, just little tiny kinks in it.
Little kinks.
Little kinks. So when I blow through it, the air gets a little bit turbulent inside. Let's see if I can hold this up to it.
Wait a minute, you're not whistling, you're blowing right into the tube.
I am not, I'm just blowing. But can you blow into that tube?
Yeah, I would just.
It's kind of hard. Oh, it's big. You got to get the air really going. Yeah. Yeah.
It's the coolest sound, I have to say. I've only done this a million times. So what's happening is the air pressure builds up and lets go. It builds up and lets go. And that creates pulses in the air, which we hear as sound. And when it's small, as Andy had, it's higher pitched. When it's big, as I've got, it's lower pitched. Oh, we're just crazy up here. We're crazy.
But, you know, I've got another piece that's too hard. It's kind of too heavy to spin around. It might hurt somebody. And it's got a little mesh inside, just a little piece of metal mesh on the inside of it. And what we're going to do is get the mesh hot.
How will we do that, Andy?
Well, I don't know how we will do that. I'm missing my glove, but we'll give it a shot. Should I find the glove?
You need a glove?
Well, I might need the glove.
Let me say, dude.
I got the glove. I got the glove.
You know what Uncle Bill says?
Safety early.
Well, gloves are tools. Gloves are tools. Even if you have a glove on, you can smash your thumb.
All right, let's heat this baby up.
We're heating it up with this ordinary blowtorch, propane torch. Wait a minute. Are you doing that?
I'm not doing that. Are you doing that?
Wait a second.
It gets hot. The air blows through the mesh. Gets a little
Show them the
turbulent.
mesh. Please show them the mesh.
I don't think they
Everybody can see it perfectly,
I'll
right?
get the mesh here.
You guys up there, you see the mesh? Sure you do.
You got it? All right, good enough. So, I'm going to try to drink the sound.
Drinking the sound?
I'm going to drink the sound in, and then spit it back out.
I hardly know this guy.
All right, here we go.
Wait a minute.
So what happened? Do it again?
Well, do you want me to say? Or?
You say.
So, everybody, you may have heard the expression, hot air rises. And that's true here in a gravity field, but it only rises when there's cool air around it pushing it up. Without cold air, the hot air doesn't rise.
So heat it up horizontally.
Heating it up horizontally.
No,
Oh,
stick
yeah,
that-
geez,
stick
sorry,
that in there.
man,
There we
sorry. We're heating it horizontally. There's the torch going in.
All right.
And we ain't got no nothing. Employing a double negative for comedic effect.
The sound tube of science.
It is the sound
Sound
tube
tube
of
of
science.
science, ladies and gentlemen.
So, when there is gravity with cool air, it pushes, it squeezes the warm air up. And that's how hot air balloons work. If you go into outer space with a hot air balloon, nothing will happen. One of my favorite stories is an astronaut, Oh, his name. He was on Apollo 13, but he wasn't Lovell. It was,
This person said Tom Hanks.
no. It'll come to me in a sec, sorry. So he found on Apollo 13, if he sat or held himself really still, he could keep warm because a layer of warm air formed around him, just like a blanket. There was no gravity to squeeze the warm air off of him. It's a hard test to run. You have to be stuck in outer space for 2.5 days. But one guy has done it. It's cool.
We have a super secret scientific instrument. Hear the alliteration there? 3 S's
It
in a
is,
row.
I love that.
The super
Secret
scientific
science
instrument.
instrument.
Yes. It's called a plunger.
Plunger, we're plunging.
Yeah. So we need a volunteer. Right here, you. Come on up here. Come on up here.
Coral, can I say coral,
What
the
is your name?
color?
Ani?
How do you spell that?
A-N-N-I-E.
Don't use your real name.
This person claims to be Ani. Everyone say, hey, Ani! Ani, how strong are you?
I'm not very strong.
She says she's not very strong. So what I'd like you to do, I'm going to put this on here. It's a
I'll
plunger.
hold this, you get
got
ready.
that?
Yeah.
I'm going to put, well, hold it horizontal for a second.
Holding horizontal.
I want you to, let me cast the magic spell. I want you to lift that off. It's hard. Pull hard.
Oh, brilliant.
Oh, well,
You
no.
must be exhausted.
Awesome job. That was fantastic. So Ani, this time I'm going to use it like a plunger. And he's going to hold it horizontally. And you need to pull, I'll be behind you so that you don't sue us for spinal injuries, okay? I'll catch you. But I really want you to pull this sucker off, okay? Are you ready?
All right.
By the way, this is how you use a plunger. When you have a problem at your bathroom at home, just like this. Oh, yeah. Is that how you, anyways.
I'll call you next time instead of doing it myself.
So he's got to go ahead and grab it, and I'll make sure you don't fall over. Maybe. Well, there! Brilliant. How hard was that?
It's kind of hard.
So
Say it again.
Kind of hard.
Kind of hard.
we're scientists, we ask questions. We're going to ask her some questions about this to figure out how hard it was. Have you ever heard of milk?
Yes.
She's heard of milk. Have you ever seen a milk gallon?
Yes.
Could you lift one off the ground? Could you lift 2 off the ground? Could you lift 3 off the ground?
Maybe.
How many could you lift off the ground?
Maybe 4.
She said maybe 4. So right when you pulled that off, as hard as you were pulling, was that the strongest you could have pulled, do you think?
No.
So how many milk gallons do you think that was? 3, 2,
3, 2.
3. All right, thank you very much. Now, thank you. Now, it turns out, you guys, we have a much larger plunger. Thank you very much, Anna. You're great. Thank you. We have a much larger plunger. We are going to play tug of war. It's Team Hamlin versus Team Bill Nye.
I picked Donna Grace. I'm picking Donna Grace.
No, I was going to go for Donna Grace.
Dude.
Okay, Donna Grace is on your team. So, you guys, I have a bigger plunger. I'll show it to you. It looks like this. It's a match set to that one. And it's got a little black O-ring on it that sticks out just the tiniest little bit. So see, very similar. Very similar.
Are you going to lick the O-ring?
I am not going to lick this O-ring. Now, can I hold that horizontally? The other way. The other horizontal. There we go. You got it? Now, there's air trapped inside. There's air pressure here pushing this down. About how much pressure, Bill? Would you say is pressure
in
on the
English
top of
units,
this?
in the old English units, about 14.7 psi.
About 14.7.
What I mean is 1,000 hectopascals.
Wait. What he means is one of these on every square inch. Every square inch, there's one of those pushing down.
Crushing you.
Crush. Now, is there air?
Enormous atmosphere.
Bill, can you demonstrate that there's air below here? Are you sure? Is there air?
Yes.
Okay.
And I'll prove it to you. I'll turn it over. There's air below it now, too.
So, is air pushing on both sides?
Why, yes, it is, Andy.
All right. Is there air inside?
There's got to be.
We trapped air inside, so it's pushing back. So can I try to pull it off? Pull it horizontal
knock
for me.
yourself out.
All right, I'm going to try. Super easy.
Brilliant.
No problem.
Yes.
But this one has a nozzle that we can suck the air out. Can you hand that to me for a second?
I'd love to.
So, if I suck the air out of this, it's now really hard to pull apart. But the thing is, my lungs are not that strong, we brought something that's a reverse bicycle pump. So a reverse bicycle pump just sucks instead of blows. All right, so let's get that on there. Donna Grace,
show everybody the gauge.
All right, so you got to squeeze that as hard as you can, as many times as you can, until this needle comes around. See the needle?
Oh, does the camera see the gauge?
Can
we put it up here?
put the camera? Whoa, wait, whoa.
I'm so sorry.
I'm good. Okay. All right, we got it. Okay, squeeze, squeeze, squeeze. Keep on going. Keep on going. More and more. She's sucking the air out. Little more. Come on, squeeze it. She says she's not that strong. All right, Bill, did you want to give a last squeeze for good measure? Okay, good enough. So we've pumped the air out
Look
there.
at this. We've collapsed this tube.
Yeah.
That's how hard we are getting the air out.
So, can you throw that back in there? So
I
you
will
guys,
gently place it.
these are not just handy handles. They happen to work with the gigantic ropes that I brought. So we're going to play tug of war. All right. So we have Team Hamlin and Team Bill Nye. Bill's going to pick 7 more people.
7?
I'm going to
7
pick
more people?
8 people.
Sir, you come on up here. We're going to get some people. You, sir. You, sir.
1, you.
We need some girls.
1, 2, you. 2. Good. 3, you in the Minnesota. 3.
Aquamarine.
4, right there. 4.
Yes, cool. How many do I have?
5 in the bow tie.
1, 2, 3,
5 in the bow
4,
tie.
5, 6, 7.
5 in the bow tie.
Yes.
All
right,
6
people.
of the shirt with pie on it. 6. 6. 6. Right with the other bow tie. 7. And right here. 8. 8. Do you have your team?
Yeah.
Okay.
Yeah, you got a problem?
You understand that you're going to
Because I'll
lose.
give you a problem.
Do you understand that you're going to lose?
I
Hey,
don't see how that's possible.
Team Hamlin, let's get it in. Get it in. Get it in. We're going to say, go
Hamlin! 2, 1.
Hamlin! All right.
Yes.
All right.
Bah.
Okay, so come on up.
Le carabinier.
There we go. Grab the rope, you guys.
Carabiner.
Grab the rope.
Are we allowed to knot the end?
You are allowed to knot the end, but you need to come way up here. We all
I
have to
know,
get on
this
the stage.
isn't especially good
way
knot
up here. We all have
craft
to,
here. Let me
way
get
up
this
here.
going.
Way up here. Way up here. All the way up. Make sure the rope is nice and straight.
Why don't you get up where everybody can see you? Please get up where everybody can see you.
So, hey, Bill, this person asked, what if she pulls it really hard, it comes apart, and then it hits her?
Oh, well, don't let that happen, because these are hard to clean. These are really hard to get clean.
So, the thing is, if you did not get picked, you're hoping that they pull this apart, because what a lawsuit, right? Right? So are we going to pull hard? Are you guys going to lose? No! All right, you got your aim there? Okay? I think I don't even need to play, but I'll jump in if you need me. Okay, now, this is 16 people pulling against air. Wimpy air. Are you ready?
Yeah,
Are you ready? Go! Oh, they need my help.
Oh, what the heck is happening?
Come on. Hey, it's just air. Work harder.
It's just air.
It's just air. Okay, stop. Let go of the rope. Let go of the rope. Who won, Bill? Who won?
I think we won. I think that was pretty clear. Do you want to say science won?
Science!
Yes.
Thank you all very much. You can have a seat. Thank you.
Oh, thanks, you guys.
Thank you so much, you guys. So, now, when I do this show with the physics majors at Hamlin University, we go to elementary schools all the time. And I always tell the front row to be careful about this next part, because, Bill, I'm going to let the air in. And it's got to be a lot of air, right?
It's got to be a huge amount of air.
I mean, it just defeated 16 people. So, I need to hold it up next to my mic. You guys in the front row, take a deep breath, because I'm going to suck the air out of the room just for a brief minute, okay? So take a deep breath.
It's going to be a rush.
3, 2, 1. Are you okay?
Yeah, I was pulled over here.
Do you want to try pulling that off? The tug of war of science, let's see it! Bill Nye!
It is cool. So, a famous demonstration in Magdeburg, Germany, where the guy had teams of horses who could not pull the plates apart. They were spheres, hemispheres. It is a striking demonstration.
I got it.
Because it means that we are living in this crushing atmosphere all day and we don't even notice it. On the Earth, we have about 1,000 hectopascals. We have 1 atmosphere of pressure, as we say. What is it in the old units? 14 point something, 15 psi, pounds per square inch. On Mars, if you go there, there's only about 0.7% as much. So there's only like 7 hectopascals, so less than a hundredth. And if you go to breathe on Mars, you'll notice right away. You're this.
You want to do Bernoulli first?
Oh, I think we should Bernoulli.
All right.
Yeah, oh, man.
So,
Anybody from Switzerland here? Oh, Bernoulli was.
you want to do the sheet of paper?
Well, I'm blowing on it?
Yeah, you're showing them how it can blow up.
That's it?
Well, do it some more. Come on. So,
If I blow over the top of it, well, let's try it this way.
make sure it doesn't hit the nails.
It moves toward me if it were a little more flexible.
So, do you need a bigger sheet of paper? I mean, there's a lot of people. Could you use a
Sure,
bigger sheet?
yeah, we need a bigger sheet of paper.
I've got a bigger sheet of paper
Oh, of
for you.
course we do.
I've got
Yeah,
a bigger sheet of paper. So, do you want to try blowing that first?
sure.
Sure, you want to try it? Here, I'll get the plunger for us. All right. Would you like more air? I brought a better blower. You want
That one?
No. I'll just hold this.
Oh, cool.
I'll hold this. You grab the blower.
Oh, this old thing?
Yeah.
Why, I can't help it being noticed to an electric cord.
Shoot over. All right.
And we're not even in the Blue Man Group. Ah, Joe, sorry, my bad. My oversight.
Hey. Oh, I got it.
Ah. Oh. It's just air, people. What?
Oh, sorry. Were you
What'd
talking?
you say?
I was asking you a whole bunch of safety questions.
What did I say?
I don't know. So how did that work? I don't understand.
It was magic.
It was a magic.
No, it was. So, as the air goes past the balloon, the momentum of the air molecules is exerted in the direction of the flow, in the direction the wind's blowing, and then the air molecules at the same temperature don't have much push to the side. So the atmospheric pressure in the room holds them against the ball, and the ball stays in the airstream. As the ball starts to go out of the airstream, there's more atmospheric pressure as you penetrate this flow going past. It's blown back in, and the same the other way, as if by magic. Anyway, the guy who discovered this and wrote the mathematics was Bernoulli, and we all rely on it every day for everything. Yes, Andy.
All right, so Bill, we were talking about pressure before.
We were talking about pressure.
I told everyone that if I got to do a show with Bill Nye, the money shot that I wanted, the one photograph that I wanted, was you standing on my chest. Are you willing?
Oh, yeah.
Okay.
Look at you. You're a robust young man.
So, yeah.
No
so
doubt very fit, standing on your chest. Even if I were to jump from here, say with ice skates on, you wouldn't feel a thing.
Yeah, no, that'd be good. Well, hang on a second, though.
Let's take a precaution.
But if you were to put all your weight right here, it would crush me. Can we distribute that a little bit?
Yeah, that would be bad. But
Okay.
if we were to use this ordinary piece of plywood shown here, did you get this at the mall?
Yeah.
Which way do you like? Concave up, concave
It
down?
doesn't matter to me.
This one I think looks
All
more
right.
impressive.
All
So
right.
he said he's willing to do this.
Yeah, let's do it.
I will gently step up. 3, 2, 1.
Bill Nye, the science guy, ladies and gentlemen! Wait.
You want me to jump?
We can step this up a notch.
Yeah.
We can step this up a notch because I was taking all of your weight and I was distributing it over lots of areas of my body.
Spread out.
I think we could do more than that. Thank you, Shayla.
Andy, this is where you and I are different.
This is a nail bed with 2,000 nails in it. And I am pretty sure. Oh, whoa.
No, you're just stabilize it. I mean, you guys, look. I mean, these are sharp.
So, I think I can distribute my weight on the nails. And I think that I can distribute Bill Nye's weight on my chest. I think I can do it all at once. Do you want to see it?
Go down stage a little bit.
Oh, down.
Oh,
Okay.
no, I see what you mean. No, stay
I'm
there.
on the rug.
Yeah, my bad. Yeah.
Yeah, no. But we can move the whole ruck. Let's do it. There we go.
Nicely done.
So, the thing is, there's a movie where this guy does a handstand on a nail bed. That is impossible. If I try to put my hand on here and really put it on there, in fact, I got a little poke. I got a little blood here. So,
Way to
that's a
go
dumb
for
idea.
science.
But my feet are bigger than my hands. Thank goodness. Right?
Yeah.
My feet are bigger than my hands. And also, man, I really got myself. So, yeah, Bill Nye. So, also, the part of your body with a low percentage of nerve cells is your something back over here, whatever it's called. So we'll do it.
I got a Band-Aid in my wall. We'll get to it in a little bit.
Excellent. I'll just suck it out right now. Here we go. Okay. So, my weight is on the nails, no problem. Let's try the plywood. No problem. Now let's try the Bill Nye. Yeah!
Andy, that is cool, man. That's really cool.
Okay, can you help me up now? Or did you want to put some other stuff on here?
I'd like to put something else on there.
Well, you might find something behind the curtain.
Yeah.
Big gray thing.
Oh, one of those. Hey, cool. Andy, while you're down there.
Oh yeah, thanks, man. Right on the tip of that one.
Wow, ouch. Kind of the worst place. You were showing off.
I was showing off.
Give it a
Thank you,
wrap
man.
there, yeah.
Awesome. So what, you're gonna help me up or what?
No. Do we have
I
one
need
of
help.
these? Andy, if you don't mind, put this on.
Oh, okay. What, do you mean just to help me up?
Yeah. And I'm going to wear these.
Okay.
Just a cinder block, Andy.
Okay, so we're done now. I can get up.
We're almost done.
No! No.
You're very confident in the nails.
All right, I'm confident. Let's do it. I can do it.
So my claim, based on Andy's claim, is that if I hit the cinder block while he's lying on a bed of nails, he'll be okay because the pressure of the many, many nails is spread out over his robust man of science back. So I don't know how much time you spent with cinder blocks, but they are frangible. You can influence their shape with percussionary modification. Are you ready?
I'm ready.
3, 2, 1. Woo! Andy Runquist, ladies and gentlemen. So you guys, as soon as you get home, do it on your way. So check out sophia.org. It's how you can advance your academic career at your own home, at your own pace. There are over 25,000 different videos. Some of them are mine. And with these, we hope we can work together to have a better understanding of science around the world. And dare I say it, change the world. Andy,
One last thing, Bill.
Bob
We got one last thing, man.
It's a good thing.
What's this?
It looks like a balloon animal.
It is a balloon animal. What's inside of it?
Poison, no, air.
Okay. Yeah.
They're comfortable.
So let me see that for a second. So there's air inside of this, and the air is all running around really fast. It contributes to the pressure we talked about a bowling ball in every square inch. It's puffing it up. But if we slow it down, what happens if you slow down air molecules?
They take up less space because they're pushing on the walls of the balloon less strongly.
So this is liquid nitrogen about 400 degrees below zero.
Minus 320 Fahrenheit, minus 196 Celsius.
Close
thereabouts.
enough. If I put it in here, all the air inside cools off.
Wait, hey, Andy, seriously, man. The only thing that goes wrong with liquid nitrogen is here.
Thank you, man. Thank you.
See, by the way, the charming thing about liquid nitrogen, it looks fantastically dangerous, but it is most of what's between you and me right now is nitrogen.
So, do you think I can fit the whole thing in?
I just don't think so, Andy. I don't see how it's possible.
So now if I pull it out, it slowly warms up, and your balloon animal has more kinks in it. Wait, did you put this in here before?
I got a feeling somebody else did.
Here's the balloon animal that Bill put in. As it warms up, the air starts to push. It pushes harder. There's not more air, it's just all of them are moving faster.
It's not magic, it's... Yes.
All right.
So liquid nitrogen looks fantastically dangerous. But if you move fast, you can handle it. I recommend against wearing gloves if you ever get into this, because not that I know, but I've heard it gets in your gloves. The other thing is if it gets in your shoes, it sounds stupid, but it's really hard for a few seconds. So Andy, what on earth do you plan to do with this happy liquid nitrogen?
Well, Bill, I don't know how long you've been in Minnesota the last few days here, but we can see our breath when we're outside. Why is that? Why can we see our breath? It looks like this.
I believe it's because of vampires and zombies.
Exactly. So the vampires and zombies are in your breath. No. There's just water vapor in your breath, and this is so cold that it turns it into a fog. But
so the water vapor, we forget is a gas, changes to a liquid for just a moment, and then you see it as a cloud, little tiny droplets of liquid, and then it evaporates again in just a moment. That's moisture in my breath. Anybody get thirsty this time of year? Yes, not a coincidence.
So we've been boiling water for the last hour, so this is producing steam, similar to fog and clouds, and this is really good at taking super hot steam and making it visible. So we'd like to end our show today by adding liquid nitrogen to boiling water.
Oh, come on, what's more fun than that? It's like blowing stuff up.
So, one more time, thanks to Bill Nye!
One more time, Andy Runquist! Hamline University! 3, 2, 1. Oh.
The cloud of silence!
Thank you all very much. Sophia.org. Check it out.